in welcoming Anil to the stage.
Thank you, Ranjini, for that introduction. Should I turn this away? This mic? Is that okay?
Yeah, this one.
Well, thank you for the introduction and welcome everyone. It's a real pleasure to be giving this particular talk. It's kind of a meta talk about telling stories. So it's a story about telling stories. And it's the first time I'm giving this particular talk. So there might be rough edges and we'll see how it goes. But basically I wanted to give a sense of what it takes to come up with story ideas that can span the length of a book. So oftentimes if you have an idea and you think that it would be great in a book form and you go to an editor or an agent, and they'll most likely tell you that, oh, this is probably just a long feature and not quite a book-worthy topic. So I just want to give you a sense for if you ever decide that you want to write a book, how much information kind of can be held over the length of a book and how you would think about structuring such a book, right? And maybe a little bit of background. Anjali mentioned that I used to be a software engineer. So around about a little over 20 years ago, I decided to make the switch to writing. And at that time, I really thought I was going to write fiction. So in fact, I had started writing a novel and written a couple of chapters and signed up with Penguin India to actually write that novel, had a contract. And after signing that contract, I didn't write a single word, literally not one extra word after signing that contract. Basically because I think I didn't know how to structure that novel. I mean, I had the idea, but couldn't quite figure out how to put it together. The other possible reason, though I think it's more of an excuse than an actual reason, was that when I was writing fiction, it always used to be as an antidote to doing software all day. So I would come back in the evening and writing was a relief. But then when I became a science journalist, I was writing all day for a living, so it was not possible at the end of the day to come back and do more writing. So part of it, and I still think that's an excuse on my part, not really the reason why I didn't write fiction. But that book kind of was mothballed. And one of the things I was trying to do in that book was bring out a sense of feeling for physics. I used to love reading about physics, and there was a certain way I felt when I used to read lots of different popular science books on physics. And somehow I wanted to capture that sense in that work of fiction. Of course, that never went anywhere. So I remember sitting down with my editor at one point and telling him that, look, I don't think this fiction thing is going to work, but I maybe want to do a non-fiction book that also tries to get at the same issue of how do you generate a certain sense of awe about what is happening with physics. And so I proposed to him, just out of the blue, that I'm going to write a book where one chapter is going to be about a visit to a mountaintop to write about telescopes, and the other, an alternate chapter would be on a visit to a mountaintop to write about a monastery. So I was going to alternate mountaintop to see a telescope, mountaintop to see a monastery, and then he listened to me for just literally 2 minutes and he said, you know, I think you should just move the visits to the monasteries to the ends of the book. They should be bookends, and let the book be about physics. And so that sat with me for a while, that idea. And then at some point I became the physics news editor at Neuroscience. I was in London at the time, and I was visiting California to just do some research on what is happening with physics. And I was meeting a lot of physicists at the time, trying to get a sense of the key issues that physicists are thinking about. And I was interviewing one cosmologist whose name you may or may not have heard now. He's very famous now, but at that time he was still relatively unknown in the broader community. Professor Saul Perlmutter, who won the Nobel, I think, in 2011 or 2012, I forget, for the discovery of dark energy. But when I met him, it was 2004. He hadn't yet won the Nobel, so it was rather easy to meet him and have long chats with him. So, and it was while I was talking to him about what's happening in physics, I kind of told him about this idea that I want to visit mountaintops to write about telescopes. And and he was the person who planted the seed in my head, saying, why are you restricting yourself to mountaintops? There are all these other extreme locations where amazing physics is happening. So that was the beginning of the kind of the seed for what became The Edge of Physics. So that was the first book. It's called The Edge of Physics in the US and UK. In India, this book was published under the title The Edge of Reason. So same book, exactly the same book, different titles. Basically, in terms of how this book came together, the first thing I had to do was figure out what were the big physics questions I was going to tackle. And these were the big questions in 2005, 6, 7, 8, and most of them are still big questions, they're unanswered. So one of the unfortunate things about this meta talk about writing books is that I won't have the pleasure of digging into the science questions as much. In fact, not at all, so you'll have to forgive me. I'm just going to mention these big words without actually telling you what it means. If you know about them, great, but I apologize in advance because there's lots of concepts that we won't have time to get into. But basically, these were really big questions, and some of them are, most of them are still very big questions in physics. So the nature of dark matter, the nature of dark energy, there's something called the matter-antimatter asymmetry, the origin of mass. This is probably the only one that has been satisfactorily answered since the time I began writing this book. The origin of mass, you would have all heard of the Higgs boson, the discovery of the Higgs boson at the Large Hadron Collider, and that is directly related to the origin of mass. The question about are there other universes out there, and then this huge problem in physics about reconciling the physics of the very large, which is general relativity, with the physics of the very small, quantum mechanics. And in physical systems where both gravity and quantum mechanics have to be applied or taken into account together, these two theories are not compatible. And so there is still something very profoundly missing at the core of what's happening in physics, and people are still working on coming up with a theory of what is called quantum gravity. So these were the big questions. I had to first identify what kinds of physics questions I was going to tackle in the book. Once that became clear, then the next step that I really wanted to travel to extreme locations. So if there were two experiments that I could choose from, invariably I chose the one where the geography was extreme. There was something about wanting to write about these extreme locations. I wanted it to be a travelogue. I wanted it to be writing that somehow evoked a certain feeling, not just because of the physics one is describing, but because of the people working at these locations, the instruments they were building, and the geography of the place itself. So the next thing that I started doing to try and figure out how to go about writing this book was identify a set of key locations that I wanted to visit. So I just want to take you through a very quick tour. Again, apologies, we won't get too deep into each one, but I'll just give you a sense for the various places that I got to visit. So I don't know how clearly you can see this. So the first trip I made was to something called the Very Large Telescope. This is up in the Atacama Desert in the Chilean Andes. So the telescopes that you see there, by the way, I should mention these. That particular photograph is not mine. I should have put a copyright notice out there. It belongs to the European Southern Observatory. So I guess you'll be putting it on YouTube. So we should somehow try and fix that. Or at least I'm saying. So that particular picture is for copyright. So the Very Large Telescope. Astronomers have funny ways of naming their telescope. This was the largest 8-meter class telescopes, and these were the largest set of 4 telescopes, where each mirror is 8 meters wide in diameter and is made from a monolithic piece of glass. So the telescopes that are being built now, which are much bigger, are not being made from a single piece of glass. So these were the last sort of really big telescopes where the mirrors were made from single pieces of glass. So I was there to both understand how these telescopes played a part in the discovery of dark energy, but also to understand why do astronomers go to such places to build their telescopes. And it's atmospheric conditions there. For instance, they have almost something like 300 plus days of cloudless skies, and not because there are no clouds in the sky, but because of the specific atmospheric conditions there. The clouds are brought down below the summit of these mountains. So when you're standing on these mountains, you're actually looking down at the clouds rather than up. There are no clouds up in the sky, and that has to do with the climatic conditions along the coast of Chile. Same things happen in other parts of the world. So cloudless sky, dry air is very, very important for astronomy, that the air be dry. That water vapor can be a huge problem when you're observing literally single photons of light coming from galaxies, billions of light years away. And there's absolutely no light pollution there. Chile has very, very strong light pollution laws. So this is a pristine environment for doing, especially optical astronomy. So that was the first trip I did, and then the second one, not too much later. That was sometime in 2004, and then in early 2005, I got to go to Lake Baikal in peak Siberian winter, because that's the time when these Russian scientists were doing their work. You literally had a 2-month window to visit them, and there are lots of reasons which I won't go into as to why they had to do it in winter, but I got to experience Siberia in peak winter, and that, I don't know if you can see, the white stuff that you see is the frozen lake. This lake is about 800 kilometers long, 40-50 kilometers wide on average, about, I think, 7 to 8 kilometers deep. It's a massive body of water, right, and pristine, extremely clear, and it's that clarity of the water that is key to the experiment. And what they have are these, call them artificial eyes, photomultiplier tubes that are sunk deep into the lake, that are watching for signs of a neutrino from outer space hitting a water molecule. And when the neutrino hits a water molecule, it generates something called a muon, and that muon races through water faster than the speed of light in water. Not faster than the speed of light, but faster than the speed of light in water. And that muon creates the equivalent of a sonic boom, but in the light spectrum, and these artificial eyes are watching for that blue light that is generated. And so I got to visit that, see how they do all this work, and the entire effort became, in terms of the book, it became a matter of chronicling what it is to do physics in these environments, and what is it about the geography. I mean, the geography of the Atacama Desert was very different from the one at Lake Baikal, and whereas those were optical telescopes, these are things underwater, right? So in a sense, very, very different scenarios, but they're all feeding into the same questions in terms of what physics, or in this particular sense, astrophysics, cosmology, and astronomy are contending with. After that, I got to visit the Large Hadron Collider. This was to see the detectors that were being built at the time, so you could still go in. It wasn't yet sealed up. And again, that picture is a standard stock picture that is supplied by the LHC or CERN, so not mine. Again, that was an effort. One of the strange things about going to the LHC was I had wanted to write chapters which involved a lot of drama, like going to the Atacama Desert or going to Lake Baikal. And you go to the LHC, which is in Switzerland, and there's literally no drama. If a bus says it will come at 10:27, it comes at 10:27. Nothing ever goes wrong. So there's literally no drama involved with your travel when you're going to Switzerland. So all of the drama in this chapter happens underground. So the drama is about traveling 100 meters underground to the site of the the Large Hadron Collider. It was a very different chapter to write, but quite a challenge. The other underground place that I got to visit was something called the Sudan mine in northern Minnesota. This is a mine that has been taken over by physicists. This is a mine that was mining iron ore back in the 1800s and early 1900s. And when the miners left, they left behind 27 levels of mines. And so the physicists had literally gone all the way down to the 27th level. And today, if you were to take the mine shaft down all the way and go in there, you would see this. This is a physics lab that has been built half a mile underground. And the reason why they're half a mile underground is because they use that half a mile of rock that's above them in order to look for the particles that they're looking for. So this is what's called cryogenic dark matter search. This particular detector, well, the picture that you see here is of something called a neutrino detector, which again I won't go into. There's an adjacent hall. Again, we're talking half a mile underground, just next to this where the dark matter detector was housed. So this again, this became a story of traveling all the way deep into the mine and writing about how this was built and the physics that's being done. And this has been a search that has been going on for decades, trying to find dark matter, and still no luck. There are lots of such detectors still functioning in deep underground mines around the world. The other lovely trip was to go to the top of Mauna Kea in Hawaii, where there are something like 12 or 13 telescopes, maybe even more now, including one of the largest telescopes ever built that is being constructed right now, called the 30-meter telescope. So those two things that you see out there are the Keck telescopes. They were at the time the largest telescopes in the world. They were 10-meter class telescopes. And remember I told you that in Chile, the very large telescope was made of, each 8-meter mirror was a single monolithic piece of glass. These were 10-meter class telescopes which were kind of made with segmented mirrors put together. Completely different challenge in terms of building these big mirrors. And in this photograph, you can see what I was referring to. The clouds, because of the inversion layer of the ocean around, the clouds are actually pulled down below the surface of the mountain, so below the summit of the mountain. So at the summit, when you're looking up, you're mostly looking at cloudless sky. So amazing place for astronomy. Then another trip that I got to make was to go to the Karoo in South Africa. This was in 2007. At the time, the Karoo in South Africa and Western Australia were competing to be the site where this thing called the Square Kilometre Array, which is the world's largest, which will be the world's largest telescope. They were competing to be the site where it would be built. And so I got to go and see the land literally, because there was nothing there. It was just to be able to write about what kind of land and what kind of sort of atmospheric and environmental conditions do you need to build such a sensitive radio telescope. So just like Chile had kind of laws against polluting the region with light, South Africa has created what's called a radio quiet zone, and this is extremely well protected from the radio noise that would otherwise make a mess of things for radio telescopes. Then, some of the most amazing experiments and experiences I had was in Antarctica. So the first picture is showing you a long duration balloon being filled up with helium. This is a balloon that, when it reaches its cruising altitude of about 40 kilometers up in the upper stratosphere, it has a volume that I think about 1 million cubic feet of helium. So, but at sea level, because it's so cold, the balloon never quite fills up fully, and it only expands to its full volume when it ascends all the way to about 37 to 40 kilometers, and it's carrying payloads which are about 1 or 2 tons, right? And the payload is essentially circling over the South Pole for 3 weeks. There are very particular climatic conditions that settle over the South Pole during the Antarctic summer, and so I was there to witness the launch of these things, and it was just astonishing. So I wrote about that, and the physics angle here was that if these detectors, in particular the one that I was observing, if it could detect even a single particle of what's called anti-helium from outer space, it would be some sort of signature that there are galaxies or stars made of antimatter. Nothing so far. That mystery of why the universe is made of matter and why we're not seeing any antimatter out there still remains a question, because according to the way the theoreticians work, soon after the Big Bang, matter and antimatter should have been created in equal amounts, but we see only one kind of matter. We're calling it matter, we could just as well call what we are antimatter, but the other kind is missing. And there are some theories in physics which try and explain why that asymmetry comes, while at the same time people are trying to look for antimatter in outer space also. No signs of it. Then from there, 3-hour flight to go to the South Pole. So that picture that you see, so by now these pictures are mine, so I don't have to tell you about copyright notices and things. So this picture is basically the arrival and departure lounge at the South Pole, right? That you can't see it clearly in that picture, but that plane is on skis, and when it lands at the South Pole, it has half an hour. The engines are running. It can't stay for any longer than half an hour because the skis freeze, and the plane then has to expend even more energy to take off. And they can't they can't keep running for any longer than half an hour because they'll run out of fuel. So it's essentially within half an hour you have to deplane, and then the rest of the people have to get on the plane. All the cargo has to be loaded, and the plane has to take off. So it's quite amazing. And I was there to kind of report and write about something called the Ice Cube Neutrino Telescope. So this is just like I told you in Lake Baikal, they have artificial ice deep inside the lake looking for the collision of neutrinos from outer space with water molecules. Here they have something like, at least at that time, this was again 2007, they had 4,800 of these artificial ice or photomultiplier tubes embedded deep inside the East Antarctic ice sheet. So in order to do that, they had to drill 2.5 kilometer deep holes, and it's not really a drill with a mechanical drill. It's you're melting a hole that is 2.5 kilometers deep and about a third of a meter wide, and there are about 60 or 80 of those holes that you have to drill and put all these detectors in, and within a day the entire thing freezes. And so you have today these artificial ice embedded in the East Antarctic ice sheet looking for neutrinos from outer space. And since the writing of the book, these neutrinos have been seen. That this probably is one of the most amazing experiments that has had phenomenal results. So this was all the reporting that had to be done for the book, right? And then in terms of book ending, I also visited the Mount Wilson Observatory. This is where Edwin Hubble discovered that the universe is more than just the Milky Way, and that there are other galaxies out there, and that they're all kind of running away from us. So all hinting at the idea that at some point in time there had been a Big Bang. So this was meant to do the reporting for a chapter on the history of observational cosmology. And as part of that trip, that telescope is in Southern California, in Pasadena, near Pasadena. I came up a bit north along the coast of California to go to a monastery. It was a new Camaldolese monastery where you just cannot speak. So it was a really amazing 4 or 5 days being there, trying to capture the kind of, possibly the kind of environment that might have existed on Mount Wilson 100 years ago when Hale built the observatory up on Mount Wilson. So this became the opening chapter, and then at the very end of my trips, I went to Ladakh to see the Hanle Observatory and the Hanle Monastery. So the first picture, the dome that you're seeing, was the telescope being constructed at the time. So this is about 14,000 feet high. And when you're standing on the hill where the telescope is and you're looking further, about 4 kilometers away, you see a 400-year-old Buddhist monastery. So these two things, the new Camaldolese monastery, which was in California, became the bookend in the beginning, and this was the bookend at the ending. And I just wanted to give you a taste for the kind of reporting it took, and the amount of information that had to be gathered before this whole book came together. So in terms of thinking about book length ideas, I think really you have to think about multiple kind of narratives that are running through the book if it has to have the kind of heft that a book usually hopefully does, right? So in this case there was travel writing, there was experimental physics, because all these people were building amazing experiments. There was also a whole bunch of theory that had to go, an exposition of the theory that had to be in the book. So it was some combination of 1/3 travel writing, 1/3 writing about experimental physics and the people building these instruments, and about a third was all of the theory that goes into supporting these experiments, right? So, and when this book kind of was about to be published, my work was done, my editor's work was done. She was asking me, do you have another idea for a book? And I spent, I think, about half an hour telling her that I want to write a book about the self. I was obsessed with having to write about our sense of self. Like when you ask yourself the question, who am I? And I was thinking more in terms of trying to understand why matter self-organizes in the first place. Like, so self by definition is something which has an interior that is separate from the exterior. There is some boundary, whether it's the boundary of a material matter organized in some fashion, or in our case as human beings, we also have this notion of a psychological self. We psychologically also have a sense for being individuals that are separate from other individuals. So I was obsessed in terms of wanting to understand both the human sense of self, but also from a physics perspective, like how on earth does matter self-organize? Why does it self-organize to begin with? Right? So I spent half an hour telling her all these things that I wanted to do, and at the end of it, she says, "You have no idea what you want to write, do you?" I mean, literally, I didn't. I just had this topic in mind, and with no sense of how a book would come together. Like, how would you put together a book, right? So, eventually, what happened was, so I'm just giving you this meta story. So hopefully, you'll see how these ideas kind of come to fruition. At some point, I was writing a feature for New Scientist. We were doing a special issue on consciousness and the self, and I was interviewing a neuroscientist, and he explained some aspect of our sense of self by taking an example of a condition in which that sense of self is disrupted. So I think he was, I don't remember clearly now, this was a long time ago, but I think he was talking about something called depersonalization disorder. He was using the way in which people, so I think he was using, he was trying to talk about how the self might be constructed in humans by looking at one particular way in which it comes apart in something like a depersonalization disorder. And as he was explaining that, I think something clicked for me. It was like this thing that I was searching for, a way of telling a story about our sense of self, about who we are. Just like for the previous book, I had gone around trying to figure out what are the big physics questions to answer, what kinds of places could I visit, etc., and kind of put that all together to form a narrative. Suddenly, just this one explanation that this scientist gave about one particular disruption of our sense of self gave me kind of an insight into surveying the literature and trying to find other conditions that also disrupt how we feel about ourselves. So, and then no worries. So basically, the effort then became one of surveying the neuroscientific, neuropsychological literature to understand how different conditions disrupt our sense of self in different ways. Right? So I ended up eventually kind of focusing on 8 different conditions. Cotard syndrome, I'll tell you this briefly, I won't go into details again here, but Cotard syndrome is a syndrome in which people very, very strongly not just believe but feel that they are dead, that they don't exist. And it's completely irrational from the perspective of someone who's not suffering from it, but from within, it is very convincing for them. So obviously it tells you something about so yeah, I mean, Cotard syndrome, the very idea that you can feel that you don't exist, at the very least should make you ask questions about why do we feel we exist. I mean, they are two sides of the same coin in a sense, right? I mean, none of us hopefully here feel like we don't exist, but the fact that somebody can feel like that internally and be convinced of it also should give you some insight into the mechanisms that lead to, quote unquote, in normality, you feel like you exist. So that was one of the conditions that I looked at in detail. There was Alzheimer's. So again, one of the things about our sense of self, if you were to be asked who are you, you're most likely going to give a narrative answer. You're going to tell somebody the story of your life, like just like Ranjini when she introduced me, that was a story, a small story about who I am, but that's a narrative. It's not the same as saying, I feel like I am standing here. It's not about the bodily self or the psychological self, it is a narrative self. And in Alzheimer's particularly, the narrative self comes apart. So you can see how by looking at different conditions in which different aspects of the self start coming apart, you can begin understanding the manner in which the brain and body together give us our sort of holistic or complete sense of self. So right now, my sense of self is not just my story, but it's also the feeling I have of being a body occupying a certain volume of space, standing here. So I have a perception of my body. You know, I can move my arms around, and without even looking where my arm is, I know where it is. How does that happen? So all of these mechanisms that are at work, moment by moment, you know, the brain and body are computing. So there are various aspects of our sense of self when you start dissecting it, and you realize that when you look at the ways in which it comes apart, you can start piecing together how it's constructed in the first place, right? So this entire book was an effort in trying to make sense of the human sense of self. So in order, just to give you a sense for the kind of reporting it took, so I had to talk to, of course, neuroscientists, neuropsychologists, and neurosurgeons, because they were the people closest to understanding the phenomenology of these conditions. And and also I met a lot of people who were very kind enough to share their experiences of what it means to be, you know, let's say, suffering from schizophrenia or Alzheimer's. Alzheimer's, of course, if you're talking to someone with Alzheimer's, it has to be someone with early or at the most mid-stage Alzheimer's, because by the time they get to late or end-stage Alzheimer's, there's no way to communicate with them anymore. And there was lots of discussions with philosophers and theologians also. All of this had to come together. So in terms of the material for the book, the information came from multiple sources, right? And also reading, take schizophrenia for instance. Again, if I was talking to someone with schizophrenia, by definition they were able to reflect on their own situation and be able to communicate what it felt like to have schizophrenia. So by definition it was not very extreme, because they were able to, you know, they were not so much in the throes of psychosis that they were in a position where they could see their own psychosis in a way, right? And that's hard in itself. That's a separate problem when someone is suffering from, has psychosis, but it's also sometimes completely anchored in reality, and they sometimes don't know whether they're actually experiencing something that is a result of their psychosis, or are they experiencing something that is real. So that has, you know, being someone with mild schizophrenia is hard in other ways, but if you have very severe schizophrenia, then communicating or understanding their experience also from the outside becomes really difficult, because their psychosis is really serious. So how does one, as a writer, understand what that might be like, and if you can't talk to the person who's actually suffering from it? Turns out there are people who have written a lot about it. For instance, there's a really beautiful and disturbing book called Tell Me I'm Here, written by Australian, I think a journalist, I don't remember exactly, but she writes about her son. So a first-hand experience of what it was like to witness her son going through very serious schizophrenia, right? So in a sense, you had to also read a lot in order to grapple with this subject. All of that again came together in this book, right? So, where did that go? This one. So the man who wasn't there, and basically the entire effort of this book became one of trying to get the reader to appreciating what is the question that philosophers and theologians and neuroscientists are grappling with when they try to answer the question, who am I, right? What is it about that question? Because each one of us, if we are asked that question, A, will come up with different answers. B, I think the question itself means something very different to each one of us. But when philosophers and theologians and, you know, neuroscientists are arguing about it, they are trying to argue about something very, very particular. And of course, the answers are still not forthcoming. At some point, the answer still remains elusive. But the whole effort of this book was to try and get the reader to appreciate that this is the kernel of that question. That at least we can come to a point where we can agree that this is the part of that question that still remains unanswered and still remains somewhat of a mystery. I don't want to call it a mystery in some mystical sense, but in the sense that it hasn't yet been fully understood. So this book happened, and just like the previous book, now had a different editor, and editors, you know, it's their job to commission new books, so they're always talking to the writers. And even as this book was coming out, my editor started asking me about what I wanted to do next. And I was so deeply sort of focused on this subject of consciousness and self that I still wanted to continue writing about it. And I talked to him about multiple ideas, and nothing worked. Same thing that happened with the previous editor, where I kept talking about these generic ideas, and somehow there was no story there to be told. There was no way to string all of this together that in a way that could span a book, right? So it just became a lot of back and forth, and then out of exasperation, literally, at that point, that I couldn't sort of convince him of anything, I sent him a 4-page write-up about something I had written many years earlier on quantum mechanics. So I'll come to this. But basically, what had happened was, before I wrote the book on the self, I had written about 4 or 5 pages on the idea that there's a story to be told about something called the double slit experiment. And I had sent it to my agent, and he dismissed it, saying, there's no way this is going to work for a book length project. It's probably at best a long feature. So I dropped it, and many years later, after the Man Who Wasn't There was published, I ended up at that point more or less in exasperation that I couldn't come up with any idea. Just to appease my editor, I sent him that 4-page write-up, and to my surprise, a week later, he comes back saying, this is the book we should be doing. And it took me about a month to accept the fact that there was a book in that topic. And so, how many of you know the double slit experiment? Okay, fair number, good. So anyway, there's no time to actually get into the intricacies of this, but I'll briefly tell you very quickly. Like a double slit experiment is essentially a very, very simple idea where you have a source of light. That source of light is shown on a barrier with 2 slits that are cut on it, and the light goes through those 2 barriers. On the other side is a screen, and the question is, what do you observe on the screen? So your intuition tells you that because the light is going through 2 slits, you should see 2 bars of light on the other side, right? You don't. You see that pattern of dark and light, light and dark, sort of, it's an interference pattern, right? And in that particular scenario, the dark strip is actually it's a photographic plate, so it's a negative. So the dark strip is actually where there's more light, and the white strip is where there's almost no light. So essentially, you're getting these bands of light and dark, right? And this is something you can explain rather easily with standard classical physics and classical optics. If you have a laser light, just treat like you take any of these sources of light, it has to be monochromatic. So if, let's say, you had lead laser light shining on that, you would see that band, and it's relatively easy to explain. Not relatively, it is easy to explain as to why you should see that. It's almost like a wave of water is going through the 2 slits. It diffracts from each slit, and then those 2 sets of waves eventually interfere with each other, and you get this interference pattern. But what's amazing is that if you do this with what are called single particles of light, or single particles of anything, we know from quantum mechanics that light, this light can be described as a wave. This stuff that you're seeing right now, there are so many photons that are hitting us that the whole thing can be treated using wave optics. But quantum mechanics tells us that all energy comes in quanta, that there is a quantum of any electromagnetic field. And so now, if you imagine this experiment where you have the ability to send single particles of light, you know that this particle of light cannot be divided any further, right? And you're at any given time, you're just sending one particle, and that particle is confronted with 2 slits, and your intuition tells you that because this particle now cannot be subdivided into smaller bits, it has to go through either one or the other, right? So now your intuition says that on the other side, as you keep sending these particles one by one, and there's a photographic plate on the other side collecting information about where these particles are landing, it's like you're shooting bullets at these 2 slits, and they have to go through one or the other, and on the other side you should see them lined up right behind the 2 slits. Again, that's not what happens. You get that interference pattern again, right? Each particle behaves like a wave, and even though it's a single particle that you're sending. So at any moment in time, there's only one particle in that experimental apparatus. And again, there's the whole point of telling you this is, and if it's not making any sense for those of you who don't know more about this experiment. That's not surprising at all. This is an extremely confounding experiment, even after you understand more about it. And that in a sense was what this book became, right? So I had to figure out how to take this one experiment and say enough about it that could, take a reader on a journey over 300 pages. So first of all, you have to explain the double slit experiment and give a brief history of quantum mechanics. And there are lots of quantum mechanical concepts like the measurement. There's no time to get into the details here, but there are conceptual issues that are very particular to quantum mechanics, like the measurement problem, the collapse of the wave function, these notions of superposition and entanglement, all of these things. You can explain pretty much anything that you are confounded by in terms of what's happening in the quantum world or in the theory of quantum mechanics by using the double slit as a model experiment. Like, you can literally understand all of these concepts by looking at what's happening in that experiment. And then over the last 100 years, there have been numerous variations of the double slit that have been done, increasingly more sophisticated. It's almost like physicists are trying to be one step ahead of the photon to try and sort of cheat the photon, and it doesn't reveal the secrets that you want it to. I'm just being a little hand wavy and flippant here, but basically, the theory tells you what should happen very clearly, and so they design increasingly sophisticated experiments. It turns out a lot of these experiments are all variations of the double slit, and or not all experiments in quantum mechanics are variations of the double slit, but there is a kind of body of work in terms of experimental physics, experimental quantum physics, which are variations of the double slit. For example, Wheeler's delayed choice and the quantum eraser experiment, and there are a whole range of these things. And so the effort at turning this one simple idea of, telling the story of quantum mechanics through the lens of this one experiment, how do you find enough that has happened in quantum mechanics that can be brought to bear over the course of a book by just using this one experiment, right? You start with the most simple experiment that was done, the first time it was done, the double slit, not in a quantum mechanical way, but in a classical physics sense, was done in the early 1800s. So from then on, you can track the history of this experiment, and it still continues to be mysterious, right? The 1800s one was not mysterious, but by the time we come to quantum mechanics and the way these experiments are done now, it's really, really extremely confounding. And you can use this experiment to start understanding all of the foundational work that's happening in quantum mechanics even today, right? Because there are very confounding conceptual problems about quantum mechanics, about the quantum world. There is the theory, there is the mathematics. The mathematics clearly tells you what should be happening, but interpreting that mathematics in terms of trying to figure out what it tells us about the nature of reality is a difficult problem. And so there are any number of interpretations that are trying to make sense of the mathematics and what it's implying about the nature of the quantum world and the nature of reality itself, right? So one of the things that this book does, one of the things that I had to do in order to try and figure out how to kind of turn this into a book-length story, was to find all the different sort of big interpretations of quantum mechanics that can also be viewed through the lens of the double slit. So as far as the reader is concerned, they're being taken on a journey from start to finish by just starting with the simplest version of this experiment, and you keep ratcheting up the difficulty of that experiment as you go, and hopefully the reader is being carried along with the increasing difficulty. And then you start talking about all the different interpretations, like Bohmian mechanics, collapse model, many worlds, interpretation of quantum mechanics. So it just became this journey of trying to find a thread that you can weave through the work that has happened in quantum mechanics to tell the story about one experiment, while at the same time it's the story of it's the larger story of what's happening in quantum mechanics. And so let me see. And when this, it was interesting because I think my editor, when he saw that small sort of 4 or 5 page proposal, he was particularly intrigued by the fact that maybe it was a small book. And because at that time, I don't know if you remember, anyone has read Carlo Rovelli's brilliant little book. It's barely 100 pages. right? I forget what it's called. Does anyone know what I'm talking about? Yeah. 7 Lessons in Physics. Yeah, so it's a brilliant little book. It did extremely well. So for a while, all publishers wanted to publish small books on physics. So I think my editor saw my small proposal and thought, oh, let's publish a small book on physics. And unfortunately, this turned out to be another 300-page book. So his hope for a small little, look-alike of another popular book didn't quite work. But this was, for me, an extremely intense experience, because just like the book on the self, I think I was really at the edge of my own understanding of this topic, like trying to figure out for yourself all of these conceptual things, while also grappling with how to put it together in a book. One of the key things that differentiated this book from the previous two in terms of the writing of it was that the quantum mechanics book has a narrative structure that is very common in science books, which is you just literally follow the narrative that science gives you. So there is a certain timeline to the progression of ideas in science, and if you just follow that, that story has kind of a narrative force to it. So you can just start in 1800s and write about everything that has happened in chronological order, and because in science ideas build upon ideas, that storytelling automatically has a narrative force. Whereas the first two books suffered from a problem, both of them had that problem, which is that there was no such narrative timeline that I could depend on. Like, let me take The Edge of Physics as an example. The first chapter was the historical account of what happened on the Mount Wilson, in the Mount Wilson Observatory, the discovery of the expanding universe, etc. But after that, every chapter that I wrote was about physics that is happening today, right? So what that does is, like in chapter 2, you're talking about, let's say, dark matter, which requires you to explain the physics as it's currently understood, at least the theory of it. Chapter 9 was about the Large Hadron Collider, which is talking about the Higgs boson, which also has the same particle physics that needs to be talked about. And you don't have time, in terms of the storytelling as a writer, to build up the knowledge in chapter 2 about all the stuff you need to understand about particle physics in order to understand the dark matter experiment. So every chapter suffered from this problem of not having the time and space to build up the chronological sort of sequence of ideas that have happened in science in order for the reader to, or you as a writer, to grapple with the topic. Same thing with the self. So if you're talking about the self from the perspective of Alzheimer's in chapter 2 and the self from the perspective of the bodily self in some other chapter, both of them are dealing with equally complicated ideas simultaneously. So you don't have time in chapter 2 to build up a level of understanding about all the difficult issues that philosophers and theologians and neuroscientists are grappling with. Whereas in the quantum mechanics book, it was relatively straightforward, right? You just went very slowly, decade by decade. And so for a storyteller, the first two books posed a very different challenge compared to this one. And when this book finished, it was around the time that I realized that I was beginning to write more and more stories about machine learning. So this was 2018, and it all seems like an age ago now, but there was a time when there was no ChatGPT, nobody knew what machine learning was, at least only the practitioners knew, but most of us outside of the field had relatively little knowledge of what was going on. But as a journalist, you start noticing that, okay, you're seeing more and more papers coming out that are using machine learning for this, machine learning for that. And when I used to write about particle physics or neuroscience, I never had the illusion that I could do that research. So I was perfectly happy to talk to the scientists, understand the research, and then write about it. But when I would start encountering papers on machine learning or anything to do with software, there's a part of me that woke up saying, hey, this is something I could do. So it was very conflicting, because on one hand I wanted to write about it, on the other hand I actually wanted to understand how to build these systems. And fortunately I got a fellowship at MIT for a year, where you just have this extraordinary privilege of basically doing anything for a year, right? You propose a project, and within the contours of that project, you do whatever you want in terms of attending lectures at MIT and Harvard. And I went back to school, literally. I went back to CS 101, sat with a bunch of teenagers, well, not a bunch, 300 teenagers, and learned programming all over again, something that I hadn't done for 20 years, and started building little machine learning projects. But it was all very rudimentary knowledge. It had been so long since I had done anything like that it all felt very foggy. And then COVID happened, and I ended up sequestered in an apartment for a long time. And just to keep myself engaged, I started watching all these YouTube videos on. Apart from watching a lot of Netflix, I was also watching YouTube videos on machine learning. And at some point, somebody at the door. At some point, I realized that some of the mathematics that underlies machine learning is actually very beautiful, and I very selfishly decided that I wanted to write a book about the mathematics of machine learning. Right? Selfishly, in the sense, one of the things I realized by now was that in order to write these books, you have to learn a hell of a lot. So, and I loved that process. You do really get very deep into your subject, and I knew that if I got to write a book on the mathematics of machine learning, I would be forced to learn it in a way that would be much deeper than if I was just learning by watching YouTube videos. So I wrote a proposal, identified a whole bunch of ideas in machine learning that would make for a story. I'll tell you a little bit more about that in a bit. And then I was pretty sure that this was not a book that would be, because I really wanted a book with equations in it. I wanted the math in it, and trade publishers don't really like equations in their books. So I was, but I did send it to my editor, and very surprisingly, within a week he comes back saying, we should do this book. I wasn't expecting that at all from a trade publisher like Penguin Random House, which is where this book is being published. And so for the last sort of 3+ years, I've been spending time learning how to code, learning the math, interviewing the researchers. It's been a very different process in terms of writing a book. But so this is the one that's going to come out in a couple of months, 3 months from now. And what did this involve? So you're trying to construct a social and mathematical history of machine learning. Right? That was the whole idea here. And this is a a very nerdy, geeky book, meant for people with probably a high school level, at least a high school level math education. So some people who have encountered some amount of calculus, some amount of linear algebra, etc. And but are also willing to stay with the math. Like someone like me, when 5 years ago, when I didn't understand this stuff, but I had done some math in my college. So for someone like me who has forgotten all that math, now encounters a topic like this, you still have to stay with it. It's not trivial in that sense, right? So this is it became an exercise in trying to understand both the historical context of what has happened in AI and machine learning over the last since the 50s, right? So you hear about neural networks and deep neural networks today, but this work actually began in the 1950s, and there's a whole arc of history here about what these researchers have been doing. It's only now that things have come to a head, and we are seeing all this furor over ChatGPT and large language models. But there's been extraordinary amount of work that has happened over the decade. So it was all an exercise in trying to understand what are the key sort of advances that have happened in machine learning and AI over the last literally 70 years, 75 years, going back to the 50s. So again, I won't go into details about what these are, but these are all different ways in which you can build machines that learn. So you have to identify that and figure out why these ones were necessary, because there are others that I chose not to write about. I chose things that I thought were the most representative of the conceptual things I wanted to get across. I had to figure out what was the mathematical minimum that I could, that I needed to explain in the book, so that a reader would sort of continue wanting to read the book. So there is some amount of linear algebra, some amount of calculus, probability and statistics, optimization theory, right? All of these things have to come in a way that doesn't feel very didactic, and it was a challenge. But like, how do you explain aspects of calculus without showing the reader how to differentiate a function, right? So you had to do some hand waving, some hand holding, all sorts of tricks that writers use normally to keep the narrative flowing. I also had to figure out what were the most important sort of ideas that underlie what's happening in machine learning today. Again, I won't go into the details here. So these were, some of the things that I had identified. Also, there were stories to be told about the people involved, right? People who had actually built these systems. So there's a historical narrative here that also was important. Again, just like the quantum mechanics book, this one had a timeline. I could just start in the 50s and keep going, right? Decade by decade by decade, idea by idea. So it wasn't difficult in terms of building up the complexity, right? You don't have to start by talking about large language models. You can talk about something that happened in the 50s, and that's much easier to understand, right? And you slowly ratchet up the difficulty of what you're explaining. Hopefully by the time the reader comes to the final chapters, they don't realize that actually you have increased the complexity quite a lot. If they encountered chapter 10 right away, that would seem a whole lot more difficult. But because they've gone through 1, 2, 3, 4 all the way to 10, hopefully that you've carried them along conceptually. So it also involved all the reporting, talking to all these people, and constructing a narrative that, all said and done, also meant embracing the math. I really did not. I made it very clear in the proposal that I did not want to avoid the math. And I was still quite nervous towards the end, thinking that when the editor finally would look at the draft, and he would say, "This is way more math than he had bargained for." And again, I'm still very grateful to him that he didn't flinch at all. I mean, so there's stuff like this. There's pages and pages of this in the book. So yeah, I mean, what else can I tell you about this particular project? It started well before large language models. It was sometime in October 2020. So none of this hype was there at the time. I mean, in the community of people building these systems, I think they were all, aware of what was going on. But from the public's perspective, this was not at all what it is today. So basically, things just blew up last year, right? So the math that you need to understand what is happening in AI kind of more or less ends in the 1990s. There's not a huge lot of amazing mathematical work that has happened since then. A lot of the innovations that have happened since the 1990s have to do with the amount of data that you have to train your machine learning models, the amount of processing power, like GPUs, etc., that have come to the fore. So there have been technological changes that have made the revolution possible, but the mathematical ideas kind of stopped in the 1990s. I could have ended the book in the 1990s, and it would still be a fairly complete narration of the mathematical ideas that underpin machine learning. But of course, GPT happened, so I had to put in an epilogue addressing this current craze. And it turns out it was actually very interesting to do that, because if you are just confronted with what large language models are doing, it feels very, very mysterious and maybe scary or amazing, depending on your point of view. But if you actually understand all of the math that led up to it, it's not very difficult to make sense of at least certain aspects of what large language models are doing. There are still lots of unanswered questions about what's happening inside these models and how they're functioning, but at least at a certain level of understanding, the math that leads you all the way up to 1990s helps you then make sense of what is happening with these models today, right? Or at least lets you appreciate why we need more math now to really look inside these models and try to model what the models are doing, right? So it's becoming a much more sophisticated problem, and that's a separate story altogether. But that's where the kind of book ended. So yeah, that has been the overall sort of journey of about 20 years. Like the first two books took about 5 years each, and a lot of that was because you had to build in the elapsed time, like traveling involved. You couldn't do it all in parallel, so there was a certain amount of elapsed time that was built into those 5 years. The same thing with The Man Who Wasn't There, when I was writing about the self. In particular, when I had to meet patients or people who were willing to talk about their condition, that took some time. Like it was not a journey that could be parallelized and made any faster. So those two books took 5 years each. The others have taken about 3 to 3.5 years each. So And also the nature of the reporting has changed. The first one was completely in person. I was traveling to all these places. Manu wasn't there. There was also a lot of in-person stuff. Quantum mechanics book, it was 50-50. I did visit some labs, but there were a lot of sort of phone interviews and other kinds of interviews. And then COVID happens, and this book is pretty much, this is a Zoom book, right? Like everything has happened on Zoom, so which has been a blessing in its own way, but also it takes away something. Maybe for this book it wasn't particularly an issue because of the nature of the topic, but I think for a reporter, if you're not actually meeting people in person, going to their labs, understanding viscerally what is happening, I think as a writer, it shows up in your writing. You just don't write in the way that you want to write, right? So all of these have been very different experiences, and I just hope that it gives you a sense for, you start with some seed of an idea, and if you just persist long enough, especially if you're an editor or someone who's willing to listen to you and tell you that your idea doesn't make any sense whatsoever, which I kept repeatedly being told, and then but you keep at it because there's some kernel of something in that idea that still intrigues you, and you keep persisting, and it's literally about finding a way into the story. So that in the case of this cosmology book, The Edge of Physics, there's nothing new in that book in terms of the physics. There have been other physics books, popular physics books, that have told the same story over and over again. My way into that story was by making it a travelogue, right? It was at that time, it was the only sort of effort that was about going to these places and writing in first person what you were encountering. Same thing with the sense of self. There was, there's so many books written about the sense of self. So again, my way into that story was saying, okay, I'm going to listen to people whose own perceptions of their own self is disrupted in some way, and trying to figure out what science, what they are telling you, what neuroscientists are telling you about what might be happening to them, etc. So that was the way in. Same thing with quantum mechanics. Again, there are books and books about quantum mechanics. The fact that you could hinge that whole story on one experiment over 200 years, variations of that experiment that had been done, turned out to be very fruitful. And now machine learning, again, same thing, right? There are so there are two kinds of machine learning books. The ones that are written for the sort of popular consumption, which actually completely eschew the math, they avoid the math, and they allow you to understand the subject up to a certain level, but then you're left hanging. You can't quite get at what these machines are doing. And then there are math textbooks, right? Which, like even someone like me, who was very interested and wanted to learn, I would not be able to pick up a textbook that is heavy on the math about machine learning and kind of stay with it, right? So this book was, the way into the story of machine learning was to say, okay, I'm going to tell both the sociological, historical story, but completely intertwined with the math. So the equations are there, and you don't shy away from that either. So if there's anything I want to say about these things, is that there's always a way into the story that allows you to tell something that has been told before, but in a new way with a new perspective. I'll leave it at that.
So we have some time for a few questions. If anybody wants to ask a few questions.
Thank you, that was fun. I have a lot of questions, but I'll just ask one.
Okay.
In these remote places you went to, is there anything about the character of the people who lived there for presumably years on end?
Yes.
Anything interesting that you found?
Yeah, different places have different kinds of characters. People who were, for instance, at Lake Baikal, for instance, they've been working there for, when I went there, they had been working there for 20 years on a shoestring budget. So it was probably over 20 years the Russians had spent something like $20 million. So they were such hardy people who could live on the simplest of means. And by contrast, like the South Pole, ice cube neutrino telescope was, 4 or 5 years of effort, was 300 million, night and day, right? So yeah, different character. Not to say that the effort at the South Pole was easy, not by no means whatsoever. But each place had a certain characteristic to it. The people in Antarctica, especially the ones who at the South Pole stay over during the winter, uh, to keep the station running. They are a different breed of people, very tough, amazing. Yeah, I mean, the book kind of gets into that a little bit. Without making a big fuss of it, I just talk to them and tell their stories. But that was what I wanted to get across. Somebody I met at the Atacama Desert in Chile. I still remember when he said that it feels like we are living in a submarine here. You're kind of craving for color because everything is just this drab brown. There are no trees, no blue apart from the sky, of course, but no water, nothing. And so he likened it to being in a submarine for months on end, and they're just dying to get back to a place where they can see some water and some trees. But they still persist. That's the amazing part.
So listening to your story, can you hear me? Yeah. So listening to your story, I get the sense that somehow you figured out the balance between experiencing and ideating. Meaning, like when you're in these places, experiencing, soaking in the situation versus thinking about what makes a good story, what will my audiences want to hear, that sort of thing. So this is a balance I personally struggle with a lot. Just experiencing, learning for myself versus constantly thinking about what makes a good story, what do I speak about, do I find out something because it helps the story, etc. So I just want you to throw some light on that.
You're hearing me tell these stories after all the work is done. So it seems like I knew what I was doing. That is not often the case, right? One of the things with books is if you can convince an editor or a publisher that there is a book to be written based on a proposal, and which in non-fiction you can do. Fiction, you have to write the whole book, but in non-fiction you can actually start with a proposal and maybe a sample chapter and start working on the book. But there is no way to foresee the kind of effort or the experiences that will be necessary for that book to become what it will eventually become. So you just start in the beginning, you're fumbling around. So don't let this, the way I'm presenting it now, suggest that when you're doing it that you actually know what you're doing. No, that feeling comes much later. In fact, I can tell you, my book is done now, for instance, the machine learning book or any of the other books. Writing it leads you to one level of understanding. The next level comes when you start talking about the book and explaining stuff in the book, standing in front of audiences, and you realize that, oh, that thing that I thought I had understood and wrote about it, actually I don't, and now you have to reach another level of understanding because now you're interacting. And so at every stage when I think back to what I knew about the self before I began versus after, night and day. I still remember the final 3 months that were left. I had got an extension of 3 months because I had not met the deadline, so I got an extension of 3 months. I had written chapters 2 to 8 about the different conditions, and I still did not know. 3 months to deadline. I had spent 3.5 years on it already, right? Seven chapters are done. I still did not know what I was saying about the sense of self that was particularly new or insightful. It was like something was still lacking. So this thing that you're saying that I knew, I did. But at that point, what happened was I ended up contacting 3 philosophers in different parts of the world and having these extended interviews with them. But by then I knew exactly what I didn't understand. As opposed to if I had done those same interviews 3 years prior, I would have just done a very general, tell me everything you know about the self kind of interview. Whereas now, I knew precisely what I didn't understand and what I needed to understand in order for the book to work. But it came down to the wire. It was the last 3 months where all of it came together. So before that, if you asked me, did I know what I was doing? I did. I could tell these individual stories, but I didn't if you were asking me about something more grand about how the book was coming through. So all I can say is keep at it. There's no way to,
Hi Anil, my question builds upon the previous question.
I can't hear you.
Am I audible now? Yeah. So what is the process of figuring the scope and depth of the book? Like, do you have conversation with the presumed audience? Or that seems like a very tricky balance.
No, at some level you got to write the book you want to write and just hope that there is an audience that resonates with that. There's no way to anticipate. You can't, I mean, you always, like, especially when you're writing as a journalist for a magazine, the magazine has an average reader. That average reader is your target audience. A book is not like that. You read it because it's such a prolonged effort, it has to mean something to you. And you have to hope somewhere that what you thought makes a book worthwhile is also something that others will find worthwhile. I would not keep a target audience in mind. I mean, there is a general audience. Like I know that the machine learning book, you know, in the proposal I could say that it will be somebody who has at least high school level math education. So that level of, but beyond that you can't say much. Right? So, yeah.
I love the first book and the double slit experiment, the way you structured your book. What I wanted to ask was, usually Western science writers, they insert themselves into the narrative of the book. Like, they become your reliable narrator who takes you through the science. Or how much of yourself have you been inserting into all these books as you become
Less and less. The first one was completely first person. The first book is, it's me traveling and serving as a proxy for the reader as I describe what I see, what I witness, what I feel. But even when I was writing that, my editor was extremely good at pointing out. She would draw these huge circles around paragraphs saying, you have entered this story way too much. Right? She would point out and then she would say something like, convince me that you need to be here or take this out. So it was because of her editing that I learned how to pull back. But saying that, Edge of Physics is in first person. I'm there throughout. By the second book, I had pulled way back, but it was still necessary for me to be present because, again, I was acting as a proxy for the reader. Like, if I met someone who was explaining how it feels to be depersonalized, it was through my interaction with that person that I was able to convey something, while keeping in mind that this is a subjective interaction and that I'm not the arbiter of truth here, I'm just reporting something, right? So in The Man Who Wasn't There, I was present, but much less than in The Edge of Physics. The Man Who Wasn't There isn't written in first person. I come when I need to, but I step away. Then the quantum mechanics, there's no point inserting you when there's a photon doing what it's doing, right? So I'm completely out of that. Machine learning, I'm nowhere. I mean, I'm there as a narrator, but it's not about my feelings or my thoughts or anything like that, right? It's about trying, the reader, you have a voice as you write, but it's kind of a distant voice. It's not as immediate as in The Edge of Physics.
But since you've changed your thoughts so frequently as you've done all these books, right? As you've evolved.
I can't.
Oh, so sorry. As you've evolved over the course of
You're
writing
making
these
huge assumptions
books.
about me.
So so wouldn't you be more interested in inserting your thoughts into it? I just find it
Depends on the nature of the
fascinating
book, right? I
because-
mean, it depends on the story you're telling.
But you don't think it's essential for the
Not at all.
book
Not
itself?
at all. I mean, if the story demands you, I mean, if it's something, so stories have their own logic,
Right.
right? And so if the logic of the story demands that you insert your thoughts into it, then please, yes, absolutely. But there are other stories where you become a hindrance. So there's no way I would make any sense as a first-person narrator in the machine learning book, which is about the math of machine learning. It's not something I've figured out, and it has nothing to do with my feelings. Yet you have to convey your excitement. I don't know if I'm getting that across. Yet you want to convey the excitement of the ideas and all these amazing things, but not in terms of a first-person reaction to it. It's a much more removed thing. Whereas when I was on Lake Baikal and when I went to wore completely the wrong pair of shoes to this frozen Siberian winter, I was in shoes that had no sole. I was slipping around on the ice. I could narrate my own terror to the reader. That was a very personal terror. Like, I was standing on 1 meter of ice with 7 kilometers of water underneath, and one crack and you go right through that thing. Of course, it doesn't crack that easily. But try telling me that at that time. I was petrified. So I was there. It was very immediate. but there it made sense. So you have to figure out which story demands your presence. Yeah.
So you spoke about a section in the earlier part about the large hadron collider and how it was challenging to write because there was no angle there, like there was no drama is the word used. So in that case, how do you resolve to find the structure for the writer?
So it did become a travel, like I said, travel underground. So I ended up writing about the construction of the Large Hadron Collider, right? So the construction of it had drama. So it became a story about how they built that thing, and my journey was just 100 meters underground. Nothing special about that. So it was not so much my journey witnessing that, but I just take the reader down there and we meet all these other people who then talk about what it was like to build that. So it's a slightly different journey that you're taking. It's not a it's in time through the eyes of other people who have built that thing.
This is a kind of a comment here. So I observed that the second book was kind of different from the others, the sense of self, in the sense that the other books you at least had a vague inkling or an idea of what you wanted to write about, or else you knew the topic in some way. The sense of self was more of an adventure for you, where you had to figure out the details in every aspect of it. So do you find that it was a very different experience while trying to learn about that? And do you have plans to write more books in a similar kind of way? As in on topics where you have absolutely no idea about how to approach it?
I think by the time I wrote the proposal, I had figured out the structure that I wanted and what it was that I was trying to write about. But you're very right. I think as I started writing that book, like I said earlier to someone, right, well into the writing of the book, I had written all the individual chapters and what it does to the self, but I still had not figured out some overarching sort of theme that would tie those chapters together. Like, what was it that I was saying about the self that could then unite all these different chapters and different perceptions of how people's selves were being disrupted. So that took a lot of effort. And to be honest, even when the book was done and the galley copies had gone out to people who are reading them for the first time, so the individual chapters had been read by scientists. Like if I had talked to people doing research on schizophrenia, for instance, those researchers had read the individual chapters. No one had read the overarching book. And I did not know at the time whether that structure had made any sense at all. So, I mean, I'm with you, I'm agreeing with you that that book presented a particular challenge. Not that the others didn't. Quantum mechanics, I don't know if, I haven't studied quantum mechanics with any great detail when I was in college. In fact, I don't remember studying much about quantum mechanics with any clarity. I mean, we were taught, I'm not saying the teachers didn't do their job, I'm saying I didn't understand it at the time. So the quantum mechanics book felt challenging in its own way, because there also you're trying to grapple with something esoteric, but in a very different way, right? So for me, both of them were challenging. Machine learning was different, and the first one was more a reportage. It was literally just trying to make sense of what is happening, and yeah, I think for me the second and third books were really hard.
What was in particular the part of your journey where you were like, what was the part in your journey where you decided that you wanted to write these types of books and experiencing things and then be that for the public?
I think I heard you. I think you were asking about what was it about, what made me do these books, basically. I think if I had to use one word, it will be curiosity. I think I still think all these books are, for me personally, still getting at the whole question of, you have matter on one hand and your mind on the other hand. So the whole journey of this universe from matter to mind, and these are all, even machine learning, by the way. When you look at computational neuroscience and what it's telling us about, what's happening in AI and the models that we're building, and what it's telling us about the functioning of our own biological neural networks. Not a whole lot at this point, but nonetheless not a small amount either. So for me, all of these are exploring bits and pieces of some larger puzzle, and oftentimes it's very unclear how they fit together, but in my head somewhere they all are speaking to the same question, and I can't articulate that question to you. I don't know what that is. Does that make sense? Curiosity, basically.
Maybe one more question.
Sure.
So, is it audible?
Yes.
So, my question is that from your journey from the journalist to the science writer, particularly book author, what's that one thing or one principle or methodology that has not changed over the course of time for you and in the course of this transition from a journalist to an author?
I mean, I'm still a journalist, right?
Yes.
These books are all journalistic books,
Sure.
so that doesn't change. So the one thing that stays constant is essentially, the ability to just go figure out things by reporting, by researching, right? So all of these topics, like someone was saying, they're all things you don't know in advance, like what it's going to turn out to be. But you have to somewhere trust the fact that if you persist in doing your reporting well, whether it's talking to the scientists, reading others' books, whatever it might be, like whatever research you need to do, that somewhere things will start falling into place. And sometimes they don't, and you have to work harder. But that's a constant, is being able to trust your training to do the reporting, to get at the heart of the matter, whatever that might be.
I'm sure everyone has a lot of questions. And we will have tea after this, so if you want to badger Anil with more questions, you can do that.
No problem, I don't mind.
One more go.
Could I just speak loudly?
I think they're recording, so if you might want to take that thing.
It keeps coming in.
I can't hear you.
Come forward. Is that audible?
It's on, but
You can just come ahead and ask.
That works.
Okay, the low-tech approach works.
Research is a whole different skill set, but then storytelling is an entirely different skill set. So how was that for from the transition from you being in like places like the academic level to then coming back and sitting at a desk and figuring out what fits where, and this whole art of storytelling, how did you work on that?
So, I think, I mean, I agree. That is a different skill set completely, and you need to be aware of what it means to write a story, and you're developing those skills also as you're becoming a writer. So they're developing in parallel, right? And in particular for a science journalist, they go hand in hand, because the story is about the science, and you need to understand the science in order to write the story, right? But the way you write the story then dictates what you need to understand. I mean, it's just a constant interplay of the two things. Somewhere you need to either already have an instinct for what makes a story, which I was fairly fortunate that I think, like I said, even before I became a science journalist, I was thinking fictions. Telling stories was not that difficult for me, and so that probably was a instinct I had from early on. But it's also something that can be learned, so it's not like a mysterious thing, right? So, but they are two different skills. I completely agree. Given a mass of information, turning that into a story requires an understanding of what makes a story. But these will develop alongside each other. So, does that help?
Yeah, it's
Yeah.
awesome. So talking about your process, could you tell me at least from book one versus the most recent book, what were the pitfalls, what were the places in the particular books where you were like, oh my god, what do I do? Like, I mean, how do I figure this out?
Oh, I mean, there's so many. It's not going to be, I couldn't tell you in 5 minutes. I mean, each book, each chapter, each paragraph, there's always stuff that's going wrong, right? So, I don't think there's any one thing that I can point and say that was a major pitfall. Sometimes it's the structure, right? The second, third, and fourth books, the structure pretty much was apparent to me from the proposal onwards. Right? So I could, in the sense that the structure that you see in the published version is not very different from the first draft that I wrote. That was not true of The Edge of Physics. I got the structure completely wrong in the first draft. Right, and so there are lots of things that happen. The level of detail you get into, you have to kind of, like the math of machine learning, I had way too much math in it in the first draft. So I had to figure out what to cut out and still be able to keep the narrative flowing. So all those things are, you can call them pitfalls, or it's just the process of writing a piece, whatever that might be, short or long. Cool.
I think we are running out of time, but we last
All right.
question.
In the lecture you had mentioned that Edge of Physics was called Edge of Reason in India.
Yeah.
Why?
Oh, that was a publisher's decision, nothing to do with me. My working title for that book was The Edge of Reason. In the sense that I, worked, at that time I was thinking of this a little bit more philosophically than the book is actually. So the working title was The Edge of Reason, and when my primary editor, who was in the US, they wanted to highlight the physics part, and I think they were right. It is about physics. But when the Indian publishers looked at it, they said, oh, physics is not going to sell here, can we just put some other title? I said, yeah, you can use Edge of Reason, and they said, oh yeah, great. So that's how we ended up with. But that was my working title, so I was more attached to Edge of Reason because I had been staring at that for 5 years. So I was happy to see at least one edition with that title.
Great. Thank you so much, Anil. This was a wonderful talk. And thank you everyone for being here and asking your questions. We have tea outside, so we can step out after this if you want to have a few more questions. Before we finish, I'd like to invite my colleague Karthik to present a small token of our appreciation to Anil.
Thank you very much.